that we're working on memorizing, that you don't have to worry about the derivative then. You don't have to do it the long way. It should be, what's the derivative sign? Cosine, and move on. You know what I'm saying? Now you can worry about other stuff. Because what I'm going to ask you is what's the equation of the tangent line for the sine x function at x equals pi? That's what I'm going to ask you. You know what I'm saying?
Yes.
The test isn't just going to ask you, what's the derivative of cosine? You know what I'm saying? You're going to need that information like that in order to answer questions like this. If you're doing a tangent line problem, what's the first thing you should do? I wouldn't do that first. I would find my point first so that I don't plug the thing into the wrong thing. You know what I'm saying? If you plug in, if I follow my point first, you plug in pi into the sine equation, and what do you get? Well, sine of pi. What's the y length of this reference triangle? Do we agree with 0? Okay? This is your point. The y length of the reference triangle of 180 degrees is 0. So now we're halfway there. We have our point. Now we just need our slope. How do you find the slope of the tangent line? Well, what did you do? You take the derivative. The derivative is the instantaneous rate of change at any x value, or the slope of the tangent line. So y prime is going to equal? So does that mean the tangent line is cosine of x? What did I just do? What does the derivative give me? What can I do with this to solve for the instantaneous rate of change? Yes, you plug in your point to find into this equation to find the instantaneous rate of change of this function. Does that make sense, Marco? So I plug in what into the cosine of x? You plug in your x value, pi, and what do you get? Well, cosine of pi, what is the x length of this reference triangle? -1. So I have my point. I have my slope. How do you figure out what point and slope? How do you figure out the equation of your tangent line? Okay, let's do it. Point slope is what?
Y minus 3.
Y minus 0 equals? If you're still solving for b, you're wasting time and you have places where you can possibly have an algebraic error. If you have your point and your slope, you're done. If you want it in y equals form in order to graph it, Rafi, you can just add that number to both sides and you're done. You know what I'm saying? So you don't have to solve for b. If you either want, this is an equation of the tangent line. This is perfect. If you wanted y equals form, in this case you don't have to add 0 to both sides, it's gone. Then you can just add that to both sides. Does that make sense, you guys? Okay, let's take a look at one more graph. Everyone on your calculators graph tangent of x. And I want to know, when is this function increasing? On the interval -pi/2 to pi/2, not including the endpoints. So graph tangent of x. And do a zoom trig, so you get a nice clean trig window. If you do a zoom trig, it'll automatically count by pi/2s, and it goes roughly -pi/2 to pi/2. So here's my tangent of x. I'm going to hit zoom, and then 7, and it's going to give me a trig window number 2. And from -4 to 4 in the y's, and then roughly from -2 pi to 2 pi's in the x's. Now I want to know on that interval. So this is the interval I'm talking about, just this middle one, not including the endpoints because we have asymptotes there. Where is the tangent function increasing? All the time. One way to check that, and you're correct, but maybe does it slow down in the middle? You know what I'm saying? Does it equal 0 there? Does it have a, it kind of S's, does it have a, one of those, one of the asymptotes that are vertical? I don't know. One thing we can do now is take the derivative of tangent. What's the derivative of tangent? The derivative of tangent is?
Secant squared.
Secant squared. Now you can't put this into your calculator. How do you have to rewrite this? Yeah, you would rewrite it as, it's not what it should be. So I'd rewrite it just like this. So do it, and let's check the values. And let's see if this gives us the complete story. So I'm going to turn off my y1 so I don't have both graphs on. And I'm just going to look at 1 divided by, I'm going to put this whole thing in parentheses, cosine of x. I'm going to double that parenthesis up, squared. So make sure you're squaring that whole, not the x, but the whole output. And let's take a look at that graph. And what is this showing us? Your graph looks different? Make sure everyone's in radians.
Alright, it's a derivative.
Well, yeah, so what do we look? Exactly, it should look different because you're not looking at the graph of the tangent. You're looking at a graph that gives you the instantaneous rate of change for any x value of the tangent function. Does that make sense what we're looking at, guys? This is a graph of the derivative. It tells you what the slope of the tangent line is for any x value. What is that graph telling you between negative pi over 2 and pi over 2? What does it mean? Yeah, exactly, Sonia. The y values on this graph are always positive. Which means what, Roxana, in terms of the original function? Yes. Looking at the entire graph, what do we see about the entire tangent function? On its domain, not including the asymptotes, it's always increasing. Interesting or no? This function is always increasing. See if you can do an n derivative on your y1 to get the same thing. Do n derivative to see if you get the same thing as your y1. So you should get that same looking graph if you didn't put in 1 over cosine x squared, or if you just physically just did your n derivative of y1. All right, we have 1 through 11 all in 15.